In today's video, we are going to talk about renewable energy sources, which is a subcategory of fuel. We are going to talk about biofuels, bioethanol, biopetrol, biogas, its advantages and disadvantages, and comparison between biodiesel and petrodiesel, as well as learning how to write combustion equations. So first, let's start with a definition. What is renewable energy sources? So what I mean by renewable is that some fuels that can be produced within a short period of time. Examples include solar energy, hydro energy, wind energy, etc., as well as biofuels. Importantly, when we talk about solar, hydro, and wind energies, those are not fuels. Because remember, our definition of fuel is to do a combustion reaction in order to produce energy. For solar, hydro, and wind, there is no combustion reaction required. Our focus for VCE chemistry in particular is on biofuels. So we will spend a lot of time discussing biofuels in today's video. Again, a definition of biofuel. So biofuel is fuel derived from recent biological materials. Most commonly, plants. So one exception is biogas, which we will also discuss later. It is derived from animal manures. Relatively speaking, it has unlimited supply. Because by definition, we can replace renewable energy with a very short period of time. So compared to petrol or diesel, we have a relatively speaking unlimited supply of biofuels. So the first very important biofuel you need to understand is called bioethanol. Chemically speaking, there's no difference between bioethanol and ethanol. They all look the same. So it has the OH hydroxyl functional group. And because, as we know, that oxygen is very electronegative, bioethanol is a polar molecule. And usually when we write the chemical formula of bioethanol, we write it something like this. So we know exactly which functional group is present. So we also need to know, like, how does bioethanol formed? How can we form bioethanol? So it is actually derived from fermentation of sugar, which is also found in plants. And on the Anabolic circumstances, this means with no oxygen present. We can actually get bioethanol from sugar. So you need to know the chemical equation of this process. So this is the formula for sugar, C6H12O6. And because we have no oxygen present, there's no other reactants. And we also know the chemical formula of ethanol, C2H6O. Note, I didn't write the formula for ethanol in this form, because here we need to try to balance this chemical equation. If you write it in the CH3CH2OH form, it is very difficult to see how much oxygen atoms you have, how many carbon atoms you have. So by writing it in this form, it's easier for us to balance the chemical equation. We can always convert it back into this semi-structural form later. So the product of this reaction is ethanol and carbon dioxide. Now let's look at how to balance this chemical equation. So I think a useful way to understand how you balance the chemical equation is you look at what I call the limiting circumstance, the limiting condition. So now it is clear that hydrogen is only present in one of the product. So it is the limiting condition. Whereas carbon and oxygen, they are present in both ethanol and carbon dioxide. So it is very difficult if you try to balance the carbon and oxygen first. Since we have 6 hydrogen atoms on the on the right, and 12 hydrogen atoms on the left, we need to double the amount of ethanol. Now we have 12 hydrogen atoms on both sides. And then we can look at carbon. So we have 6 carbon on the left-hand side, 4 carbon here, and then 1 carbon here. So we need to double the amount of CO2 present. Now we have 6 carbon, so 4 plus 2, 6 carbon on the right, 6 carbon on the left. We now look at oxygen. As we can see, it is already balanced. We have 6 oxygen atoms on the right and 6 on the left. So this is all good. So where does this sugar come from? What plant material does sugar derive from? So back in the day, we use leftover sugar canes. So this is important because it is a waste. And then we can actually turn this waste into ethanol, which can be used in combustion, in cars. So it is a very, very good thing for the environment. But now, because of this increase in demand for biofuels, we now have something called fuel crops that is designed to produce sugar required to produce ethanol. So this leads us to the disadvantages of bioethanol. Is that we need crops that are used for food is actually being replaced by fuel crops. And this have lots of problems for the environment. It can increase food shortage, especially in developing economies. So another disadvantage of bioethanol is that we can look at uh, the chemical structure. We can say it is a polar molecule, so it can absorb and attracts water. And because of this, it can damage engine parts. So that's why for old cars, it is recommended you don't use ethanol fuel. You should stick to petrol. For newer cars that are designed specifically for bioethanol, it can run on pure ethanol or 85% ethanol without damaging the engine. And the other characteristic of bioethanol is that if we think about combustion reaction, we are reacting a fuel with oxygen. So essentially it is actually an oxidation reaction. When you fully oxidize the fuel, it becomes carbon dioxide. And we look at the formula of bioethanol, it already have one oxygen atom present. So it is partially oxidized already. And we know that during this oxidation energy, we produce energy. So during this oxidation reaction, we provide energy. So because it is already partially oxidized, so it produces less energy than something like petrol. So that's one of the problems with bioethanol. But this problem can also be a good thing. Because it is already partially oxidized, we require less oxygen to completely combust bioethanol compared to petrol. So we have less emission of carbon monoxide or soot, which is a byproduct of incomplete combustion. So this is the advantages of bioethanol. Maybe I should also add, you cannot store long term. You cannot store bioethanol in long term because it absorbs water. So bacteria can actually grow. So this is the introduction of bioethanol and everything you need to know for the purpose of VCE chemistry exam. The second biofuel is called biodiesel. And this is slightly more challenging for students to understand because to make biodiesel, the process is not as simple as bioethanol. So how is biodiesel made? It is made from fats and oil. So fat is solid at room temperature and oil is liquid at room temperature. Another name for fats and oil, you will encounter this in Unit 4 chemistry as well. It is called triglyceride. So tri means 3. So let's look at what fats and oil actually looks like. So instead of drawing something like this, which takes a long time, I will use the abbreviation like this. So each here represents a carbon and then you can fill in the gap for for the hydrogens. This is called the skeleton form, which is really convenient to draw. So what does biodiesel looks like? Very, very, very long carbon chain. Sorry, this is for the triglycerides, not biodiesel. So what does triglyceride looks like? So you have a very long carbon chain. You have a carbon here. And then you have another one. Because it is a triglyceride, we need 3. Then the last one. So this is what triglyceride or fats and oil, the vegetable oil you use to cook food, looks like. So this part is called glycerol backbone. Because it's called backbone since it connects the 3 fatty acids together. And this is, as you recall from year 11, is called ester link. So how do we go from a fats and oil into biodiesel? We need 2 steps. By the way, we need a catalyst, usually KOH as catalyst. A catalyst, we will also cover this in area of study 2. Basically facilitate the chemical reaction to make it easier for the chemical reaction to occur. So the first step is called hydrolysis. Hydrolysis means add H2O, add water. And by adding water, we can break this ester link. We can separate it into 2 parts. So we separate into 3 fatty acids and the glycerine molecule. So let's have a look. So I will only draw one of the fatty acid. So before it looks like COO here. But this is not what actually happens. So the O part actually belongs to the glycerol backbone. We only have the CO here. And we know that we need to add H2O. So actually, one of the OH from H2O goes to this part, goes to the triglyceride part. And if you remember this is basically a acid, carboxylic acid. And because it has a very, very long carbon chain, we just call it fatty acid. And then let's look at the glycerol backbone. What would happen to them? So as I mentioned before, the O actually belongs to the backbone. So we already used H and O from water. So we only have 1 hydrogen atom left. So this hydrogen atom actually goes to here. And this molecule is called glycerin. And during this reaction, because we have a triglyceride, we would produce 3 fatty acids and 1 glycerin. So this is step 1. What will happen in step 2? Let's have a look. So this is one of the fatty acid. And we need to react this fatty acid with methanol. What would happen in this instance? is the fatty acid will actually join or combine with the methanol. And the byproduct is H2O to produce water. And this is biodiesel. So biodiesel is actually an ester with a very, very long carbon chain. So this is the ester functional group. And it is polar. So carbon is partially positive, partially negative, partially negative. So this is actually a polar part of the molecule. But because we have such a long non-polar carbon chain, it is overall non-polar. So what actually happens is that the OH from the carboxylic acid and the H from the methanol will join together to form H2O. And this carbon here will form a link with the oxygen with methanol to ultimately produce this biodiesel molecule. So this is what biodiesel looks like. And we need also to know the advantages and disadvantages of biodiesel. So first let's look at the disadvantages. This is relative to petrol diesel. Remember, petrol diesel is just a very simple alkane molecule with 12 to 20 carbon present. So one of the problem is it is hygroscopic. Because of the polar ester link. So water will actually stick onto this polar ester link via a dipole-dipole interaction. And this makes the biodiesel hygroscopic because water can attach onto it. And water can create lots of problems. It allows the growth of microbes in this fuel. So it can affect engine performance. You don't want microbes to grow in your engine. Another problem is because we have this polar ester functional group, the viscosity would increase. And this is particularly bad in cold climates. So it can gel or turn into solid. At higher temperatures than petrol diesel. So in cold climates, biodiesel is not really suitable, since when the fuel becomes a solid, you cannot combust them very easily in the car's engine. Another problem, which is the same as bioethanol, is we have deforestation and also competition with food crop. And this can cause climate change, as well as problems with biodiversity. because biodiesel is derived from fats and oils. People may plant lots of palm trees for the production of biodiesel. And this can cause a loss of biodiversity. So what are some of the advantages of biodiesel? So it does not contain sulfur. So during the combustion, there's no sulfur dioxide produced. And also because we have this oxygen present, as we discussed before, it is partially oxidized. So this allows for more complete combustion. So less carbon monoxide, less soot produced from the combustion process. It is also biodegradable because of the presence of water in biodiesel. So as you can see, the presence of water allows microbes to grow in this fuel, but it also means the fuel is biodegradable. So it has its own advantages and disadvantages. The problem is, how do you balance those advantages and disadvantages to make it more suitable for your particular application? The last biofuel we look at is biogas. So biogas is also released by breakdown of organic materials under condition with no oxygen. So it is commonly done in a thing called digester. And the product of this process is methane gas, also called natural gas. So around 60 to 65% of methane contained in this biogas. And another good point is that the residue from the production of biogas can be used as fertilizer. So it has a double use in this case. So the advantage is that this process prevents methane gas to release into atmosphere. And we know that methane gas is a potent greenhouse gas. It also turns waste into two useful products. Which are fertilizers and CH for methane gas. It can also be used in the same way as natural gas. So there's no compromises here, is it? Well, it also has its own disadvantages. So only 65% is actually methane, which is what we are looking for. So it has less energy when we're doing the combustion reaction. It is not pure. Contains things like nitrogen gas, hydrogen gas, oxygen gas, etc. the digesters only can operate if the temperature is above 20 degrees. So in cold countries, it is actually very difficult to produce biogas. So this is the brief introduction of the 3 types of biofuels covered in the VCE chemistry study design. We will briefly look at how electricity is generated. In particular, the efficiency of different types of electricity generation. So the coal-generated electricity is the least efficient. So in a coal-fired power plant, you burn the coal to boil the water. And then the steam from the water drives the turbine. And then the turbine produces the electricity. So lots of steps in between. And each step, you lose energy. And because of this complicated process, you have energy loss. Hence, it is least efficient. Gas is more efficient, about 40% efficiency. So 40% of the potential energy in the gas is actually being transformed into electricity. So the way is you combust the gas, and then it heats up the air, so it expands the air, and the expansion in air generates electricity. A much simpler process, and because of it, it is more efficient. So now let's look at how to write combustion reaction. How to write the chemical equation of combustion reaction. So a general formula is you have a fuel, you combine with oxygen, you always get CO2 and H2O. Always, when you are doing a combustion reaction. If it's incomplete, you can have carbon and carbon monoxide. So let's do 3 examples together. The first one, let's combust propane. So liquid petroleum gas. The chemical formula C3H8. So it is a gas. Because only 3 carbon in the propane molecule. Less number of carbon means less dispersion force. So the boiling point is lower. And that's why it is a gas at room temperature. We combine this with oxygen, which is also a gas, to produce carbon dioxide, which is also a gas, and water, which is a liquid at room temperature. So now let's try to balance this chemical equation. So the limiting factor is carbon. We only have carbon in one of the product. Since we have 3 carbon on the left, we also need 3 on the right. Now another limiting factor is the hydrogen atoms. Since we only have it in one of the product, we have 8 hydrogen on the left, so we also need 8 on the right, times H2O by 4. And now how many oxygen do we have? We have 6 oxygen atoms here and 4 here. So we have 10 atoms of oxygen on the right. So we need to multiply the left by 5. So this is a balanced combustion reaction equation for propane. Now let's do octane, which is petrol. We know we have 8 carbon molecules in octane, based on the naming convention. Because of this ANE, we know that it contains single bond only. So the general formula is C8H18. A trick is that you just times the amount of carbon by 2 and then add 2 if it's only have single bond. So 8 times 2 is 16, 16 add 2 is 18. Just something aside. For E and E, so double bonds, you just times this by 2. For Y and E, which is a triple bond, you subtract 2 extra hydrogen atoms. So this is shortcut, makes it easier to write the chemical formula. So we know that octane is a liquid, petrol is a liquid at room temperature. Again, we combust this oxygen, we have CO2 and H2O. So again, we need 8 carbons here, 18 hydrogens on both sides, so 9 here. How many oxygen do we have? We have 16 plus 9, which is 25. So we need 25 oxygen atoms. Because each oxygen gas have 2 oxygen atoms, so we need 25 over 2 oxygen gas molecules. So that's how you write the chemical equation for the combustion of octane. So 25 on 2 plus 2 is 25. So this is equal to the right hand side. Next one is ethanol. Again, everything is the same as before. Ethanol is a liquid at room temperature. We need 2 carbon here, 3 water here. So here we have 3 oxygen plus 4, 7 oxygens. We have 1 oxygen here, so we need 6 more. That's why we times this by 3 to get 6 oxygen. So now we have 7 oxygen atoms on the left and 7 on the right. So it is balanced. So we require way less oxygen to fully combust ethanol compared to petrol. So it is more easy to undergo complete combustion if we are combusting ethanol. Let's look at the energy content and energy density of different fuels. We have propane, octane, ethanol, diesel, and biodiesel. So a fact is that diesel cars have better fuel economy than petrol cars. So why is this the case? Well, we look at the energy density. So 1 liter of diesel can produce a lot more energy than 1 liter of petrol. And because of this, diesel cars use less fuel to travel same distance, since diesel fuel can produce more energy per liter compared to petrol. Usually diesel cars have 20 to 40% better fuel economy than petrol cars. A diesel car can easily do 6 liters, 7 liters per 100k, whereas for petrol cars, usually it's around 10 to 11. And we also know that for cars that burn natural gas, the fuel, you need to refill it very often, because the energy density for LPG, sorry, not natural gas, for liquefied petroleum gas is less, even less than petrol. So you might ask, oh, maybe it has higher energy content than petrol, so why it gives you a lower range? Because our fuel tank is measured in terms of liters. So you have an 80-liter fuel tank or 100-liter fuel tank. You don't talk about how many grams of propane or how many grams of octane your fuel tank can hold. So that's why when we talk about fuel economy, we use energy density. And another interesting thing is we can look at diesel and biodiesel more closely. So biodiesel can produce less energy per liter than diesel. Since we discussed already before, it is partially oxidized. Similar story with ethanol, it is partially oxidized. So it produces less energy per gram and less energy per liter. And also, if we look at the viscosity, basically how thick the oil is. For diesel, it is 2.5. For biodiesel, it is 4.9. So biodiesel is much more viscous than diesel.